don't say anything crazy. Okay. All right. So first thing I wanted to just kind of mention is that couple of things you got coming up. So on today, you should have done your performance final. If you had issues uploading, I know a couple people were struggling with uploading it. I did create a Dropbox. So with the performance final, you can either put it in the Dropbox. I know some people emailed it to me. I know some people typed it in. It's okay. Just get it to me and I'll grade it. No biggie. Don't stress about it. Just get it to me. Okay. So are there any questions on that before we move on? Okay. All right. The next thing that you're going to have is you are going to have some practice over AKS 28, 29, 30 on Wednesday. And you're going to have a review on Wednesday. So Wednesday, Thursday are going to be really important days because that's going to be your Unit 7 review. There will be a Unit 7 test on Thursday into Friday. And that's going to stay open all weekend because I know most of y'all are still trying to like play catch up. So Unit 7 test is coming up. And then the last thing that you'll have to do for us is the final exam, which is going to be May 12th. Please, if you can like make sure that you don't miss this date, that would be really, really important. May 12th is going to be super, super important for you. Are there any questions about any of those things? Are we supposed to take the Unit 7 quiz? If there's anything on eClass under that quizzes section and you're able to take it, take it. That means you're either A, missing a quiz, or B, you can retake an assignment. So I would try to retake as many as possible just to raise that grade. Okay. And again, remember, those things close tonight at midnight. So try to get them to me so I can update your grade as quickly as possible. Okay. All right. So I'm going to go over, do we still need to upload our work on paper for the final exam? If you emailed it to me, then you're fine. If you typed it in directly into the questions, then you're fine. And if you, for the performance final, yeah, I created a Dropbox just in case. I know a couple of people were freaking out that it didn't upload or whatever. Just drop it in the Dropbox. That's fine too. Just get it to me however, and we'll take care of it. Okay? All right. So I'm going to go over 17, 18 because somebody asked me to do that. Let me know if you have questions along the way. But it says Jemiah and Janae, yeah, that's her name, are selling smartphones, iPhones, and Androids. The x-axis represents the number of iPhones, and the y-axis represents the number of Androids. So I'm going to put that down. And y equals the Androids. All right. So the constraints that model the number of smartphones sold are as follows. Okay. So I'm going to explain in words what these 5 constraints mean. So x is greater than or equal to 0. Well, we can't have negative iPhones, right? So this is going to be positive iPhones. That's what this is talking about. We can't have negative Androids. So this is going to be positive Androids. Like we can't have a negative number of those. This is saying that there is at least 4, and this would be Androids sold. And then this equation right here, or inequality right here, is saying that the combination of iPhones and Androids is less than or equal to 12. The combination of iPhones and Androids are less than or equal to 12. And then this last one says that you have a max of 10 Androids. Anybody have any questions over that? Because that's basically incomplete sentences. Obviously, I wrote it kind of shorthanded. That is what you're writing for right here. Questions on that? You can't see it? You not see my screen?
I can see it.
Okay. gonna make it a little bit bigger. Does that help, Zion? Okay. Okay. How did you know positive or negative? So it's that thought of, if I had negative Androids or iPhones, I wouldn't have any iPhones or Androids in front of me. Does that make sense? Like you can't have negative number of something, like realistic, like real world stuff. Like I can't have a negative pin. Like I have to have one pin. It has to be a positive number. So that's why it's saying that there's a constraint that is X is bigger than 0, right? Did that help? Okay. All right. So suppose that the profit on the iPhones is $200 and the profit for the Android is $160. Write the objective function for the total profit for Jemiah and Janae. So the total profit for both of these girls are going to be, you can't see my screen now. Can you see it now? So Mahato, it says that you're presenting. Yeah. Hold on. Resume presenting. There we go. Okay. So suppose the profit for the iPhones, no problem. So you're gonna have this is kind of like your Y equals. So you're gonna set that equal to, and it says that it's $200 for each iPhone. So it's gonna be 200x, and then you're gonna have 160y. Okay, so this is representing that it's gonna cost you $200 per iPhone and 160 for Androids, right? So we have any questions over how I created that equation? Okay. So then it says Jemiah's goal for the week is to sell 2 iPhones and 6 Androids. Janae's goal for the week is to sell 4 iPhones and 5 Androids. So we're going to take each of these and we're going to plug them into these equations. So we're going to take Jemiah first. And what we're going to do is we're going to put 2 in for X here, and we're going to put 6 in for Y right here, and figure out how much she's going to make. Okay, so I'm going to type that into my calculator. I'm going to say 200 times 2 plus 160 times 6. And then that's going to give me 4,960. 4960. Okay. And then I'm going to do the same thing for Janae, except it tells me that she sells 4 iPhones and 5 Androids. So I'm going to plug in 4 iPhones and 5 Androids. And I'm going to plug that into my calculator. So I'm going to say 200 times 4 plus 160 times 5. And so that's going to give me 1,600. I don't think that's right. 800. No, that's right. Okay. I think I did something wrong up here. 2. That's what I did wrong. Cool. 200 times 2 plus 160 times 6. Okay, so right here, this should have been 1,360. My bad. I knew that number was wrong. So you kind of have to be careful plugging that into your calculator. So which one of these would you want to make? Like, obviously you would want more money, right? So you would want Janae, or Janae would make more profit, right? And you would say Janae would make more profit because she has a higher number. Now, this question said, would it make sense to have a negative number? And we just talked about having negative of something. Can I have a negative pin? No. So they have to be positive. Alondra, did that help a little bit?
Yeah, thank you.
Okay. Anybody else have a question over 17, 18? Okay. So we're okay on that. So make sure that you handle your performance final. If you have any NTIs, make sure you get them to me, and I'll try to grade them in the next couple of days. So the next thing I'm going to start going over is Unit 4C. Like I said earlier, your final exam is going to consist of all of the units from this semester. And so with that being said, okay, that's fine. So with that being said, this week we're going to go over each individual unit. Now, I probably won't get through all of the questions from the 4C review, but remember, I've already filmed myself working through these 4C reviews, as well as I have already posted the answer key for the review guide. So if you're like, I just want to practice it and then check my answers, it's already there for you. So I'm going to just start working through it because I know like it's been a hot minute since we've seen some of this stuff. Okay. How many questions are on the final exam? Right now it's between 15 to 20. We're kind of like trying to make it easier since it's supposed to only take you an hour to do. So we're trying to kind of condense it. So it's going to be between 15 to 20. Okay. So it won't be like super long, but it's still be a little heavy. But again, remember May 12th. Don't miss that day. Please don't miss that day. Okay. And you can take it at any point. It opens at midnight and goes until 11:59 p.m. So if you want to get up at 6 o'clock in the morning and take it, then boom, you're done. Okay. All right. So on this problem, what you're going to do is you're going to solve for x. Okay. So you've got the square root of x squared minus x minus 1 equals 2x minus 3. Now, the first thing I want to do here is I have to isolate my radical. Well, I've noticed that my radical right here is already isolated. So now I'm going to square it, right? So I'm going to square both sides. And that'll get rid of this square root. Remember, taking a square root and squaring it gets rid of that square root. So everything that's underneath that radical is going to remain the same. Over here, though, this is taking 2x minus 3, and then we're going to multiply 2x minus 3. So 2x minus 3 times 2x minus 3. And I'm going to multiply this out. So 2x times 2x is going to give me 4x squared. 2x times negative 3 is going to give me negative 6x. Negative 3 times 2x is going to give me negative 6x. And negative 3 times negative 3 is going to give me positive 9. And again, this side is going to just remain the same. Okay. Questions on that so far? So all we've done is we've gotten rid of the square root by squaring both sides. And then now our next move is to move everything to one side so that we can factor it, right? We're going to combine our like terms and we're going to factor. So over on this right side, we see that there's this negative 6 and this negative 6, and we can combine those two, right? So that's going to give me 4x squared minus 12x plus 9. And this is still the same. And now I'm going to move everything to the other side. So that means I'm going to subtract this x squared. I'm going to add this x. And I'm going to add that 1. And that's going to give me 3x squared minus 11x plus 10. Remember, you can only combine your like terms. So if it has an x squared attached to it, those are the ones that can be combined. If it only has an x to the first power, those are the only ones that can be combined. Everybody okay so far? And again, this review guide's already posted on eClass, so if you want to pull it up and like you want to print it out, that's fine, or if you just want to write it down, that's good too. So now we're going to actually factor this, and I know y'all hate factoring. So yes, you can use the quadratic formula. I will be providing you with a formula sheet. Okay, there will be a formula sheet. And it will have the quadratic formula on it just in case if you need it. But worst case scenario, you could just like write it down on your paper. That's okay too. All right, so for this one, we're going to factor. So we're going to do our little diamond or big X. So we're going to do A times C, which is going to give me 30. And my B is going to be negative 11. So I need to think of two numbers that if I multiply them together, I get 30. But if I add them together, I get negative 11. So factors of 30. And I know we struggle a lot with this. So factors of 30 are like 1, 2, 3. That's fine, Zion. That's okay. So factors of 30 are going to be 1, 2, 3, 5, 6, 10, 15, and 30. So of these, which ones can I multiply together to get 30, but add them together to get 11, negative 11? Well, I can take negative 5, negative 6, and that'll make that happen. Since this first coefficient is bigger than 1, we are going to have to put this in the little box. Okay, so I know this is a little messy. We're going to put this in the little box. And we're going to put the first term in the first box, last term in the last box. And these two terms I just found, I'm going to slap an X onto them and put them up here. Then I'm going to take the greatest common factor of the rows and columns. So from these two, I've got an X. From these two, I could probably pull out a negative 2. From these two, I've got a 3x. And then from these two, I've got a negative 5. Okay, so after you get it all the way down to here, you factor, and then you break them into these two pieces. Once you get here, you're going to put them into that y equals mx plus b format. So that 3x minus 5, and you're going to set it equal to 0. Because remember, we want to solve for x. Okay, so if I was to solve for this equation, I would add 2 to both sides, and that would give me x equals 2. Over here, if I was trying to solve for x, I would add 5 to both sides, and then divide by 3. So that would give me x equals 5/3. So x is going to equal 2, and x is going to equal 5/3. Now, one thing you do have to check is, since this is a radical or square root, you actually have to plug it back in and make sure it works. But in this case, I'm telling you it does work. So normally I would check it by plugging it back into this equation, and both sides would have to equal. If they don't, then you did something wrong. Okay? And normally what happens is normally people factor wrong. Okay, so that's the first place I would look. Questions over this? I know that's a real big refresher.
During the factoring, why couldn't you pull out a negative 5 for the negative 10x and then 10?
Why couldn't I pull out a negative 5? Like right here?
No, the under the negative 2 where you wrote, why couldn't it be a 5? Because they're both 10, right?
Here and hold on. You're saying in the box, right?
Yeah, the 10x and the 10.
This is negative 5x.
No, the one above that.
That's negative 6x. I'm sorry.
Oh, I thought that was
negative
10.
6x. Nah,
okay,
I pulled a
right.
negative 6 right here.
Okay. Yeah, I see it now.
Okay.
Okay, thank you.
Sounds good, Mahara. And again, remember, I will record this. So if you're like, I need to go work on my performance final, okay, go handle that. Okay. All right, I'm going to go ahead and go to the next one. All right, so this is graphing. And the easiest way to do this is to put it into a graphing calculator or put it into like Desmos. Desmos is a little trickier in the sense of you can't just type like square root unless you know like the little secret hidden buttons. They're not really secret, but anyways. So when you type this into your graphing calculator, you're going to go into that y equals button, and you're going to hit second x squared, and you're going to type out what's underneath the radical. Make sure that you're using parentheses. So I'm going to take a screenshot of what I just typed into my calculator so you can see it. And then I'm going to show you the picture of what it actually looks like. Okay, so this is what I typed into my calculator. And then when I hit graph, this is actually what I'm going to get. And like these, you really should not be getting wrong. Like, don't get these wrong. This is AKS 34. A lot of y'all need a little bit of help on it in the sense of your summative grade. So I would really, 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 really highly suggest you do well on this part in particular so that I can go back and I can replace that AKS 34 section. Okay. But all you got to do is type it into your calculator. Most of y'all type it incorrectly. So if you'll take a moment, I want you to try to type this into whatever graphing calculator you have. So type this one into your graphing calculator, and I'll post it in just 1 second up on here. So you're typing this into your graphing calculator. Can we still work on the extra credit even if it hasn't been approved? Yes, you can. Okay, so you're typing this into your calculator. Make sure you use those parentheses though. Turn up your, like it's on your computer. I don't know if Alana can't hear me. All right, so if you type this into your calculator, what you're going to do is you will get this as your graph. So if you did not get that, I would check on what you typed into your calculator. And this is what I typed in there. And there is a square root underneath that little black box. I don't know why it's hidden. So that's what I typed into my calculator. There's a little square root right here. Are there any questions on how you type this into your calculator? Don't miss these questions because most of y'all need this summative grade to be replaced. And it's not like super difficult, but you need to know how to type it in, okay? It does say describe the transformation. So compared to the parent function, so the parent function right here is that square root of x. You remember how I was talking about how this is the OG of the parent of this function? Like this, that is what we're comparing to. So if we're looking at this function compared to the parent function, and if we graph the parent function, it looks like this. And this is why I wish we were in class so that you can see my screen so I don't have to keep clicking back and forth. That's how I feel. Okay, good. All right, so we're comparing it to this guy right here, which is the OG, okay? So from this guy to this guy, what happened? Well, we shifted over, right? We went to the left, but how many units did we go to the left? Well, do you see how there's like this x plus 5 right here? Then we went to the left 5, and then this 3 that's out front, that's pulling this up a little bit more. You see how it kind of rears up a little bit farther up than this one? So there's a stretch of 3. So when this says describe the transformation, it's not talking about like transformers. It's talking about actually like comparing it from one function to another. Okay. So looking at this one, comparing it to the parent function. So we're looking at these two stars. Where did it go? So we see how it has this x plus 4 minus 1, right? Okay, so really that's x plus 3. Like let's simplify it. That's really x plus 3. And we noticed that from here, which was the starting point, it moved over 3 units, right? So we went to the left 3 units. Okay? If there was something outside of this radical, like if it said like plus 14, then that means that we went up 14 units. So it shifted up 14 units. Are there any questions on AKS 34? Because I really want y'all to do well on this so I can go back and I can replace. Okay, again, the final exam review has already been posted and the answer key is online as well. So if you're like, oh, I just want to check my answers, it's already on there. Okay. All right, AKS 3132. Scientists have discovered that the neck height, h, in centimeters of a female African giraffe can be modeled by the equation h equals 20 points the cubic root of t plus 29.7, where t is the age of the giraffe. What does the 29.7 represent? What does the 29.7 represent? Does anybody remember this question? Y'all can talk to me, I swear. All right, so that 29.7, so what does that represent in this equation? Well, age represents the neck height of an average female, right? So that 29.7 represents what? Looking up the wrong thing. Y'all killing me on this. Crickets. So this represents the height at birth of an average giraffe. Okay, it's kind of like the y-intercept. This is where all of them start, right? Okay, AKS 31 and 32 is really talking about analyzing key features of this. Notice how I said that was the y-intercept? Like if we plug in 0 here for t, that's what 29.7 is going to be. Like this is, if I plug in 0 right here, it's going to be 0 plus 29.7. So on the y-axis, it'll start at 29.7. So every baby giraffe is going to be at least 29.7, right? Roughly. Cool. All right. Y'all making me talk to myself today. Killing me. All right. AKS 1720. So you're going to find, okay, you're going to find x. So what you're going to do here is you're first going to isolate your radical, which fortunately for us, our radical is already isolated. And then what you're going to do is you're going to square both sides, getting rid of that radical. So remember, when we square both sides for that radical, that cancels that radical out, and everything that's underneath it is what we write. And x squared is just x squared. We are going to move everything to one side. So we're going to add x to the other side. And we're going to subtract 72 from both sides. And that's going to give us x squared plus x minus 72. Here we're going to factor. So we're going to do a times c, which is going to give us negative 72, and b is going to be 1. So what two numbers will make that happen? So I need to think of all of the factors of 72, that if I add them together, I get 1, but if I multiply them together, I get negative 72. So a couple ways you can do this. You can type this into your calculator in that y equals button, and you can type negative 72 divided by x. So it looks like this. So when I type it into my calculator, it looks like that. And then I'm going to hit second graph, and that's going to pull up a table so that I can look at the various like factors that'll help me determine what numbers we should use. So for instance, this is what it's going to look like. So out of this list, which ones can I add together to give me 1? Well, 9 and negative 8 make that happen, right? So 9 and negative 8. So when I put those into factored form, I'm going to have x plus 9, and I'm going to set that equal to 0, and x minus 8, and set that equal to 0, and solve for both. So that's going to give me x equals negative 9, and x equals positive 8. Questions on that? Okay. I know this is a lot of information. Remember, I am recording, so you can go back. You can watch it again. Because I know the first time you watch it, it's kind of like, what? So, okay. On number 5, it says electric power is defined by the equation P equals VI, where P stands for power, V stands for voltage, and I stands for current. Using Ohm's law, V equals IR, we can substitute for voltage to write the equation for electric power in terms of current as P equals IR, or I squared R. What is the equation for resistance and current in terms of power? So here's what you need to do. In terms of current and resistance, right? What is the equation for resistance? So we're looking for, what is the equation for? I don't like how that's worded. So what exactly are we looking for? That's my question to you. So what are we solving for? P, I, R, V, hoopla. Nobody likes it? No.
Wait, I gotta read it.
I feel that.
Well, I guess we're solving for resistance and current if we want to know the equation for it.
Okay, so you're saying that we're solving for I?
Yeah, I think so.
Okay, so we're getting I by itself, right?
Yeah.
So we need to put this equation, that P equals I squared R, into this other equation. So how are we going to do that when P is not even a part of this equation? Well, what if we solved for R in this equation first? So how do we get R by itself over here? This guy. What is it attached to?
I. So we gotta subtract I, and then
we're gonna divide it by I squared, right?
Yeah.
Okay. So that'll cancel out, and so that's gonna give me R equals P divided by I squared, right?
Mm-hmm.
Now I can take this mess and I can put it in for this guy, right? I can put it in over here, right?
Oh,
okay.
Yeah.
So what we're going to do is we're going to put this equation that we have right here in for that r. So I'm going to have v equals I p divided by I squared. And you told me that we're solving for I, right? So we got to get I by itself. Well, we've got an I in the top and an I squared in the bottom. Well, what do we know about exponents for these? We're going to subtract them, right? If they're the same base, we can subtract the exponents. So this can actually be written out as p divided by I. Okay, because the exponent for this guy is 1. The exponent for this guy is 2. Well, what's 1 minus 2? -1. So we're going to keep it in the bottom, right? So now we're trying to get I by itself. So we're going to multiply by I on both sides. And then we're going to divide by v. So I equals p divided by v. I know that was like mind-blowing. So this one's really difficult in the sense of you've got to read and definitely read what the question is asking, as well as you have to use 2 different equations to solve. If you're taking physics right now, you're definitely using this, or you have already used it. So just this law is not going away. You're going to see this for the rest of your probably college career, as well as high school. So don't forget this stuff. And remember me when you get famous for it, right? All right, I think I'm going to do one more. I'm going to try. We're going to skip over 7. We're going to try to do 6 really quick. And that'll be the last one because I know, like, I don't want to bore you to tears. So Kristen is solving a radical equation and determines that the equation has no solution. Which equation is Kristen attempting to solve? Okay, so here's the quickest way to do this. If I square both sides of this equation, it's going to give me a solution. Like I'm going to get some type of number, whether it's a decimal, a whole number, whatever, right? Same thing's going to happen with C. Because like I'm going to move everything to one side. I'm going to factor, blah, 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 right? D, I'm going to add that X to the other side. I'm going to square both sides. Still going to get a number. But on B, the first thing that I need to do is isolate this radical. Well, in order to do that, I have to subtract that 10, right? And that gives me the square root of 3 plus x equals -10. Now, have you ever had a square root of something and it give you a negative number? Like you take the square root of...
No.
Right. So what do you think our solution is going to be? Sorry, my bad. So what do you think our solution is going to be?
Wait, what was we're looking for the one that doesn't belong?
So in this case, I would square both sides, right? Can you see my screen or no?
No.
Okay. My bad. Okay. So if I squared both sides on this one, I would get 3 plus x equals 100, right? And then I would subtract 3 from both sides. And so x is going to give me 97. Now, if I plug 97 into this equation, watch what happens. I get the square root of 3 plus 97 plus 10. Well, 3 plus 97 is 100. Square root of 100 is 10. 10 plus 10 is 20. Is 20 equal to 0? No. So this guy has no solution. Okay. One thing I want you to keep in mind is if you ever have a square root and it's set equal to a negative number, that's automatically going to be a no solution. Okay. Like that's just a quick trick. Now you can solve all these out and find out that there's going to be no solution. No solution means that one side's going to be equal to another number that's not the same thing, right? And Otis, I think, yep, it's just me and you, man. So any questions on 6, Otis? And you can unmute yourself if you need to.
Dang, everyone left.
Yeah, right?
No, I don't think so, since there's already like the answers and stuff. I get
Right.
it. What'd you say about that rule? Oh, if it equals a negative. Okay.
Yeah, if the square root equals a negative number, if you ever have this scenario, then it's going to be no solution. You only have to solve it out.
Okay, yeah, okay, that's easy. This seems pretty common sense. It's all just solving and substituting.
Yeah.
Or not substituting, summing.
Well, and really AKS 34 is the one that I'm wanting y'all to really focus on and go back and relearn. And I think I have some videos on that, but I can go over that a little bit more on Wednesday.
Okay.
But yeah. I'm gonna hit stop recording, so it stops freaking out.